We are starting 7-3 today. What we did last class was learn about inverses, and that's going to help us today. If you notice in 7-3, I don't have a single matrix on here. That being said, we have to put these equations into matrix form, and I'm going to show you what that looks like. We're going to do some 2x2 inverse methods by hand, and then I'm going to show you a couple 3x3s using the calculator. So we're going to use both tools today. Everybody's good, ready to go with me? By your next class. Definitely by Monday. No promises before that. I don't have a lot of time today, so we will see. Inverse method. So I'm going to make this equation into a matrix, and the matrix, when we write it, looks something like this. We're going to write A times X equals B. So matrix A is a matrix made up of all of the coefficients of X and Y. Matrix X is a matrix made up of the variables of these two equations. And then matrix B is made up of the solutions. Okay. So when I write these in matrix form, I'll just write it off to the side next to it. When I do my coefficients, my X coefficients all go together in my first column. My Y coefficients all go together in my second column. And if I were to have another variable, that would go in another column. But I only have X and Y here. So my first column is 1, 3. My second column is 2, -1. And if you notice, if I were to read it left and right, those are the coefficients that are in the first equation. So my first equation is 1 and 2, which is why my first row is 1, 2. My second equation is 3, -1, which is why my second row is 3, -1. That seems to make sense, right? You're all right with that, right? Okay, my variable matrix is just going to be X and Y. My coefficients, dimension, sorry, I couldn't think of that word for a second. Dimension is a 2x2, and my variable one is a 2x1. When I end up multiplying those together, what size matrix am I going to get after that? A 2x1, good. And that 2x1 is just the answers that we had for the two equations earlier. Bye, Camille.
Bye, thank you.
Thank you. Bye, Bo. That's just my solutions. Now, the cool thing, and you don't have to write on your paper. Ooh, that's way too big of an eraser. You don't have to write on your paper with me, but I just want you to hear as I say this. The reason we're allowed to rewrite this as a matrix as it is because when I do a multiplication, if I were to multiply these two matrices together, this times this, 1 times X is 1X, 2 times Y is 2Y, and that equals 8. You guys okay with that? If I were to just multiply the matrices together, just like we learned. Yeah, 8. Yeah, sorry, it's kind of funky, 8. The second row multiplied by the column, 3 times X is 3X, and -1 times Y is -Y, and that equals 3. So does that match the equations that we had? So that's why we're allowed to write it in matrix form, is it's the exact same thing as the equations that we had. It's just organized differently. Like I said, matrices are all about just how it's organized. Nothing else about them is really different. Okay, so now in order to solve, we want to get X all by itself. So in order to get X by itself, we have to move A to the other side. And when you move A to the other side, that's the same thing as doing the inverse. Inverse of A times B. So what we are going to do by hand is find the inverse of A and multiply that by my matrix B. Do we know how to find the inverse of A? Yeah. Can you multiply two matrices together? Yeah. You've got all these skills. We just had to start at a different spot. So now we are going to work to get to that. So let's start by doing the determinant of A. So determinant of A, it's going to be 1 times -1 minus 2 times 3. I think it's actually going to be -7. -1 minus 6 is -7. Are we okay with that? Okay. Now, in order to do my inverse, I have to do 1 over -7 times my like scrambled up matrix. How would I rewrite my matrix A? Oh, I didn't label these earlier. This is A, this is X, this is B. So I've only been talking about this matrix. How would I rewrite that to do my inverse of that? -1, -2, -3, 1. Okay, now we're going to multiply those together. We're going to distribute that 1 over 7 in, and I want you to fight the urge to use a decimal, and I really want it to be a fraction. Yeah, Callie. You don't flip it for the determinant. So when we did the determinant, we did 1 times -1 and 2 times 3. You don't mess with it then. But then once we found the determinant, then we switched A and D, and then B and C's sign changed. You wouldn't get the same answer. Yeah, good question. One over 7, 2 over 7, 3 over 7, and -1 over 7. Okay. All right, the reason we did that is so now I have my A to my -1, and now I'm going to take that number and multiply that, or that matrix, excuse me, and multiply that by B. So now I'm going to do 1 over 7, 2 over 7, 3 over 7, -1 over 7 times B, which is 8, 3. And again, as much as you want to use your decimals, I'd rather use a fraction. 1 over 7 times 8 is going to be 8 over 7. 2 over 7 times 3 is going to be 6 over 7. Good with that? Okay, now for the second spot. 3 over 7 times 8 is 24 over 7. And -1 over 7 times 3 is plus a -3 over 7. All right, what's 8 over 7 plus 6 over 7? 2. If that's a little too much for you, especially at the end of the day, I know that's the same thing as 14 over 7, and 14 divided by 7 is 2. What about 24 over 7 plus -3 over 7? 3. It's going to be 21 over 7, which is 3. You don't have to write my in-between matrix. If you can do it in your head, that's fine. I just like to, really ensure that it's there. I don't want to make a little mental mistake because I wasn't thinking it through. So that's it. That's my answer. That means that my variable matrix x, y is equal to my solutions matrix 2, 3. And that means that x is equal to 2 and y is equal to 3. That means you just read across the sign. X is equal to 2, y is equal to 3. Okay, I want to do one more by hand, and then we're going to do one in the calculator, okay? So we did skills that we already learned. We did the inverse of A. We did the multiplied that by B. The one thing I do want you to write every time is like, what is my matrix coming from the equations? What are those matrices going to be? So you can write it one of two ways. We could just write our coefficients times our variable equals our solution. Actually, no, that's what I want you to write. I want you to write it this way. What's my coefficient matrix going to be? Good, good, good. And I like to know that's A, that's X, that's B. So I got to go do my inverse of A, or my inverse of A. I'm going to be quiet. I want you to try your inverse of A. Mm-hmm. Mm-hmm. All right, I've got my determinant up there. I've got my inverse matrix. I've got my answer and I multiply them together. I left mine in a decimal, but if you wanted I left mine in a fraction. If you want a decimal, that's okay. I'm gonna sneeze. Maybe not. Maybe not. Okay, we're good. All right, if you have that one done, I want you to get your calculator out because we're gonna do calculator for the last problem today. We won't get the very, very last one on this page done. That's all right. We can do it next class. Anybody have any questions on doing this by hand? Okay, so this is us using matrices in order to solve in a normal equation. Again, matrices is just an organization of the numbers. What we were given was a normal equation like we're used to using, but now we're doing it differently organized. Okay, can I move on to the bottom? Okay. All right, we're gonna do this in the calculator. So we need to get our calculators out. Before we start typing in the calculator though, let's rewrite our matrices just like we did on the last two. What's my coefficient matrix gonna be here? What's the first, let's just do columns. What's my first column gonna be? Column, not row. Column is gonna be all my x's to start with. So I'm gonna write 1, 2, 3. Then I'm gonna do y's as my second column. So that'll be 1, 1, 1. And the last one is going to be my z's, -3, -1, 5. Okay. You can write this like we have been writing it above. How I'm probably going to write this is literally what I want to write in the calculator. I want a to the negative first times b. So I'm going to write my a, I'm going to write raised to the -1, and then I'm going to write my b, my solutions matrix, which is the last number, 7, 6, -4. We're all okay with that, right? Okay. Now, what we need to do in the calculator is we need matrix A, or we need a matrix to be the first matrix that I have written here. I need matrix B, or I need a second matrix to be the second one I have written. And then we're physically going to type matrix A raised to the negative first times matrix B. So I'm going to go to my little calculator. Remember how to get to the matrix menu again? Good. Second, x to the negative first. So, and remember when you're editing, you gotta go all the way over to edit. So I'm not on names, I go all the way over to edit and I press my matrix A. It looks like I still have mine in from last class, which is good. Bum, bum. Okay. All right, double, triple, quadruple check, make sure that it's right. Make sure you have the right negatives in the right spots. Second, quit. I'm gonna do second matrix. I need to make sure B is the same as well. You can make them any matrix. I always like to kind of mess with the first couple. I don't like to have like 20 different matrices or else I forget what they're for. So matrix B is 7, 6, -4. Okay, I'm cool with that. Okay. I'm gonna give you a second. Maybe you want your matrices to match those. You want one in matrix A and you want one in matrix B, but you want them both in your calculator. Okay, for those of you who are ready, if not, I'll repeat this, so if you miss it, that's okay. For those of you who are ready, have both your matrices in, I want us to go and I want you to press second matrix and on names so that A is just gonna pop up in our calculator screen. I want you to type A. How do I raise it to the negative first? Literally the same button we've been pressing. And then now I need to go get matrix B. So I'm gonna go second matrix and I'm gonna go down on my name still because I want B to pop up in my screen, B. See how that's literally what I told you we were doing a little bit ago? Like it's exactly A, -1, B. Once you see that in the calculator, I'm gonna press enter and that is going to be my solutions. So the first number we see is what X equals. The second number is what Y equals. The third number is what Z equals. So let me write it in next to my variable matrix is equal to my solutions, which is 3.5, which is negative 3.25, which is negative 2.25. And so what is Z again? Negative 2.25. What's X? And what's Y? Yes. So do you guys see, like, I know it sounds so silly. You're like, why is she asking such a dumb question? I need you to know like what everything is, because it's very easy to get to this point and then not know X is literally the number across from it. Y is literally the number across from it. Z is literally the number across from it. Okay, that is all I wanted to do today. We'll hit the last problem and then we'll just keep going next class. I'll stop recording. You guys